Hey guys, happy Thursday. Today's title for our lesson is State Changes. I'm going to go through the slides with you, tell you about the independent work you have to do. I assume if you're watching this video, you have missed live class. And so let me get you caught up. So one thing for your do now, I have two questions here. Try to answer both if you can. I'm hoping, praying that you did yesterday's work during Wednesday when there is no class, but there is always a lesson. This lesson was about climate change and chemistry. I wanted to make chemistry feel relevant because climate change is happening all the time and it's affecting people and it's affecting some people more than others. So I wanted you to tell me one thing you remember, one thing you learned from yesterday. And specifically, can you tell me why the ocean levels are rising? In the reading we did, there were three reasons. Maybe you can just explain one or two. Do not forget that on Sunday, your homeschool connection number 2 is due. We started that yesterday. I gave it to you yesterday. You're going to have to talk to somebody at home, have a conversation about the questions on the page. Go back to Wednesday's slideshow, yesterday's slideshow. Scroll down to the bottom. It's the second to last, I think, slide. It has a video. It tells you what to do and everything. Okay. I want you to try to find a time to talk to an adult at home before Sunday. Okay. I have a scientist of the day for you, a really, really excellent one. I love sharing this scientist and her work. I want to talk about the learning target. I would like to go, I'll let you know what people did during breakout rooms. And then I'll just quickly go over these 3 different independent works that you have. Okay, Paula Villarreal is awesome. She's a Mexican computer scientist. Okay, she taught herself how to code computers. And by the time she was 15, she was making money doing it. She joined the ACLU of Massachusetts. Massachusetts is a state in the United States. The ACLU is the American Civil Liberty Union. These are people that come together and they do a lot of legal work, but they try to help people. They try to change laws. They try to, social justice is important for them. And so what she did as a computer scientist, not a lawyer, but she took data that is available from the census. This is like data that the government polls everybody and says, okay, who lives in our country and where do they live? And give me some information about you so we can know where people need the most help, where the people are who don't need as much help, things like that. Because every year the government has all this money they put out in the world for programs across the country, and so it helps to know where people are and who they are. So she took that data. She also took data on police activity, and I'm going to show you a map in a second. And she used that to show racial biasing in policing in Boston. So this is the map that I found from at least one of the things that Paula Villarreal is working on. So if you look at this map, the bluer colors, this is a map of Boston. Okay, the bluer colors, the more white people live there. The greener the colors, the darker the green, the more people of color live. And as you can see, this area is probably like a downtown area. More people of color live here. The pink dots represent police activity specifically around marijuana. So that's when people like arresting or giving citations to people for possession or smoking of marijuana. And so you can already kind of see here that so the bigger the circle, a big circle would mean a lot, and a small circle would be just a few, maybe like one citation or something. And a big circle would be a lot. You can see here where is the majority of the pink dots. They're in the neighborhoods with the most people of color up here as well. Only a few. You go out here to the places where mostly white people. This is a lot smaller amounts of police activity. This is the kind of thing that data and computer sciences can help change the world, can help make life better, because you can go and the police might say, hey, I don't know what you're talking about. We're completely fair with our policing. And you can put this map in front of them and be like, this is your data. Let me show you what you're showing, what you're doing. You are spending way more time in areas where people of color live, and you're arresting them for marijuana instead of in the white neighborhoods with predominantly white people. Many studies have shown that white people of color, people of all races use marijuana, do other crimes at the same rate. So it's not at all that people of color are have or sell marijuana more. That's not true. It's just that the police are there more. And that's what this map is showing. That's what they were able to use this map and a lot of other of their work to try to change the way that policing is working. And that, I think, is very relevant to the world we still live in. And this was a few years ago now. So anyway, that was my little rant about that. Let's keep going. I want to remind you that state changes have to do with particle attraction. All particles have an attraction to each other that help keep them close together. And if you remember from learning about water, there's a little picture of water there on your screen. Water is strangely really attracted to each other, more than other types of molecules. When the amount of thermal energy that particles have changes enough, they will either overcome their attraction and break apart, or will give in to their attraction and come together. This is called a state change. Sometimes you hear it called as a phase change, but state change is what we're trying to say because that's the words in the standard. Okay, so that's changing from liquid to a gas, from a liquid to a solid, things like that. Okay, so in breakout rooms today, if you missed it, we watched this video and we tried to fill in 1 through 5 of this picture. So let's look at this picture down here. I have a gas, a liquid, and a solid, and I got arrows, a red and a blue one, going between all of them. Okay. And so we have this one's already labeled, it's melting, because when a solid changes to a liquid, it's called melting. You probably already knew that. So what I want you to do is try to figure out what's the word from when a liquid changes it into a solid. If you can think of that word, put it here. What about what a liquid changes into a gas? Or how about a gas back into a liquid? What about a solid into a gas or a gas into a solid? You might not know all those, so watch the video and that'll help you. And I want you to think about this question at the bottom. How do you think that state changes are important to explaining why popcorn pops? Remember, we're trying to learn more to help us really be able to explain what's going on when popcorn pops. So this might be part of it. So this is what we did during the breakout room. So if you missed class, go ahead and do this now. And then you have 3 parts of independent work. So that's the last that's the last live learning slide. There's this, which is, as you notice, is a very similar picture to this, but this time you're actually going to drag and drop. Oh, you can't see because so you can actually drag and drop these. So maybe you want to put this here, or maybe you want to put this here. I want you to drag these words onto the correct arrows, because each of these words is going to label an arrow. I'm not going to tell you what the right answer is there, but you have to look back from before. Or here's that same video again if you want to watch the video like you watched on the last slide. So this should just take you a couple minutes. The video is pretty short. You're just going to practice using these words by thinking about, is it a gas turning into a liquid, solid to a liquid, etc. Okay, that's the first thing. The second thing, I want you to open up this. It's going to take you to a site. You're going to click on this. It says states. And you're going to do what it says. You're going to say heat or add thermal energy to the solid particles and observe them. When you heat a solid, it changes into a blank and then into a blank. Now click gas. Cool your neon gas particles. That would be like drag the thing so the ice pops up. And cool them or remove thermal energy from them. And then finish this sentence. When you remove thermal energy from a gas, it changes into a blank and then a blank. Can you get those neon particles to stop vibrating totally? How did you do that? So there's 2 sentences here. There's like 2 parts of these sentences. It changes into a blank and then a blank, changes into a blank and then a blank. And then a 6 is a little bit of a challenge. Take yourself, try it out. We actually will come back to this model. This website, this simulation is fantastic. I love it. And we'll learn more about pressure using the same thing tomorrow. Okay, so this should be pretty short. This one on slide 8, I think it's slide 8, is pretty short. Then you have an exit ticket. I know that the ones I gave you guys on Monday were pretty long, and so I tried to make this one nice and short and simple. Open it up, answer the questions, and that's 1, 2, 3 things, and then you're done. This is slide 3 of 3, 2 of 3, 1 of 3. That's it. If you have any questions, find your teacher, find me, ask me. I'm happy to help. Do not forget about your home school connection is another thing that's due, but it's not due until Sunday. Be good, stay safe, learn science.